Good morning, everybody. Hope it's going well for you or as well as it can. Let's go to the smartboard. Are there any questions from last week that anybody wants to ask quickly? Try to keep up with it. I will say this. I hope at least some of the topics are reviewed for you, but they may not be. And when you have new things in math, I know it can be stressful. So when we get halfway finished after the third lesson on the fourth week, we'll probably do some reviewing and won't take some new. So I'm not just hanging you out there. We'll have chances to review and go over some more things as well. Well, let's get right into this week's lesson. Here are the topics, or the topic that we're going to cover today. It's going to be an introduction to probability. John, can you hear me fine? I think I've got my volume turned up enough.
Yes, sir. We can hear you just fine.
And there's all kinds of things we talk about in probability, but many of you will take probability and statistics in a statistics course, usually a freshman or sophomore level in college. And there's several things that we can introduce and talk about now that would, I think, benefit. But here are some of the things, the topics under it that we're going to look at in the classwork and look at some examples today. We're going to look at sigma. That's in red there. This is the Greek capital S, and it's used for sum. And boy, it's used a lot in statistics. The sum of things, looking at data and adding data up. So we'll look at that and see what that does and do some examples of that numbers. We're going to start with flipping a coin and probabilities and union and intersection. There's probably, I would say a half a dozen different topics and probability they use where the sample space is fairly easy. Flipping a coin is as easy as you can get. It's binomial. It's either heads or tails. And we'll talk about that and then talk how it's related to union and to intersection as well here in just a little bit. I'm going to talk about factorials. I hope you already know what a factorial is, but if not, we're going to talk about it with numbers and statistics. The symbol for it is an exclamation mark. And then we're going to talk about combinations. What does a combination mean in statistics? Capital C is that symbol. And what a permutation means in statistics. And capital P is that symbol. So those are the topics we're going to look at this morning. I'm going to do first some examples, and then we'll work the classwork together and see if there's any questions. Okay, let's start looking at example. Let's look at sigma. Sigma first, some examples of that. Here's the first one I've written down. And if you have a question, just unmute yourself and ask. And if anyone else, if I don't hear you, stop me here in a little bit. I think I can hear everyone fine if you unmute yourself. You can do this both with or without a calculator. The arithmetic of this means this. I'm going to take the numbers starting with 1 and put in here. So I'm going to say 1 plus 2 is 3. And then sigma means you add. I'm going to then go to 2. 2 plus 2 is 4. And then I'm going to go to 3. 3 plus 2 is 5. And then I'm going to go to 4. 4 plus 2 is 6. Then I go to 5. 5 plus 2 is 7. And I'm going to add those up. And that, my answer here is 25. Now that one was an easy one. And I would hope all of us could do that by hand with a piece of scratch paper and a pencil. But if I was going to 1 to 500, there's no way I would do that by hand. I would do that on the calculator. So let's look at that for just a second, okay? So get your calculators out. It's nothing more than a small computer. And let's look at some of the sequence. We're going from 1 to 5. We're going to do this easy one. Just make sure we know how to do it on a calculator if we want to. Of n plus 2. Okay, here's my calculator. It's a sum and it's on the stat key. The stat key is right here on your calculator. And so, I will say this will look slightly different to start with because I have a newer model here on the screen, the older model. But I think you just stay with me and follow along. It'll work.
Mr. Babcock, we're not seeing the calculator on the screen.
Okay.
I don't know if you may unshare and then reshare.
Yes, that's what I got to do.
Oh, okay, okay.
We're good now, right? Okay. Your stat key is in the middle, and there's no, all of you, if you're going to college, you'll use this at least in college algebra. If you have other fields, related fields, you use it a lot more. But it's nothing more than just a small handheld computer. That's all it is, with some memory in it. And it has the statistics built right into it. Your statistics key is towards the middle of the calculator. I circled it there in red. And to do the sum of that sequence, remember, again, we've already done it. We know the answer is 25. But if we want to do it to 500, the calculator handles the arithmetic a lot better than we can. So this is one thing I did want to show you on the calculator. I'm going to do second. And when you hit second, you get an up arrow in the upper left-hand corner of your calculator. Stack. Go over. Next one is ops. And the last one, you see a sum, and it's number 5. So that's the first thing you're going to get on your calculator. That was second stack, and you go over to the third menu, I believe it's number 5 on all of your calculators. Well, this is sum of the sequence, so I'm going to hit second stat again, and go over to ops operations, and number 5 is sequence, so I'll hit 5. We can go down to it. Now this is where I bet yours looks slightly different than mine. Okay? Slightly different. All of this on the older ones, it lists it right out, but they'll look the same here in a little bit. This is what you need to do. First off, whatever's here on the expression, that's the first thing. You'll have sum, sequence, and then you want to put x plus 2. Okay? And then there's going to be a comma. I'm just going to put x plus 2. And after each time you put it, sum of sequence, x plus 2, comma. That's the way it's going to look in your calculator.
Sir, they're seeing what you're writing on the smart board.
They can or can't?
Cannot.
Okay. Well, let's just go ahead and try to put it in, and I'll show you. Just hold up a second. I'm going to show you how it should look on your calculator. First, you should get sum of the sequence, and let me put in what we're going to do here. And then I'll talk you through it.
Did everyone
How do you
see
do
how
the
to
X?
type in X?
There's,
Okay, X.
No.
I'm going to get you here in just a second. I'm going to paste this so we can all see it. Can y'all see it now?
Yes.
Screen?
Yeah, they see the calculator, sir.
Okay, so you have a sum of the sequence. Then I put x plus 1. And your comma is above your 7. And then I put the variable x, and the variable x, and there's several x's you could use. This is the one that's the easiest to get to on your calculator that I just circled. Beth, could they see that what I just circled in blue?
No, the X is right by the green alpha key, guys.
To the right of it. And just make it look just like it is here. The newer ones, name, it tells you what you're doing by the name, which I kind of like, but the old work just as well. Do you have that in?
Unmute yourself and tell him if your screen doesn't look like his, and he'll walk through it again.
Where the heck is the alpha key on this? Oh, I found it. Never mind.
What's your second key? That's a good question. Don't say never mind. You got to get familiar,
Okay.
just like anything. Believe this or not, whenever I go buy a new phone, I take Mrs. Jacket with me. She knows how to make my wife. You've made my wife so happy on Facebook, Beth. I just want to tell you that up front. I still don't do Facebook, but I don't know what we would have done the last 3 months without it. Okay, now you're going to hit enter. And it gives you the answer, 25. Does that make sense? Now,
Sir, that gave you 20, not 25.
I think instead of x plus 2, you typed in x plus 1.
okay,
I did not get that answer, dude. I'm confused.
I'm going to go change that. That's what I like about this. It was x plus 2. You give me 25.
It's 25.
You can go back and without doing it again. And what I really like about it, if I was going from 1 to 500, it would probably take the calculator 5 seconds to do 500 numbers. And
Sir, will you go through the calculator one more time for Brittany?
Yeah, I
Yes,
was gonna ask if you
please.
could just go through it all again for him.
Sure. The first thing you want on your calculator is sum. And you hit second stack. Now that stack key is 1 below and 2 over from your second key. And you go over, ops is the second one, you go over to the third one. And it's number 5. You see number 5 says sum, enter. Oops, I didn't do that. Let's try that again. Second stack, 5. And it's 6. So you want sum. And this is a sequence. It's x plus 2. So I got to tell the calculator it's a sequence. So to get the sum of a sequence, again, I hit second stack. And this time it's under ops. And again, it's number 5. So you just hit 5. Now mine goes and then asks for the expression. I'm going to change it here to x plus 2. I went down and totaled the variable x and said, why do you have to tell it x? I could do 4 or 5 different variables. This is made for really hard problems. You might think this one's hard, but boy, they can get a lot harder. We started at 1. And this time, instead of going to 5, I'm going to go to 500. I want to show you how it works. That's going to be a huge number. And I want to go by ones. You say, well, why wouldn't you want to go by ones? Well, I could go by half. In calculus, I might want to go by a 10th each time. I'm going to come down here in mine. I'm going to paste it so you can see it. That's the way it's going to look on your calculator. I'm going to hit enter. Takes it a while. See, it took about 3 seconds because it had to add 5. It had to do that operation and do 500 numbers. But still, it gave me the answer. It's a neat tool if you want to use the technology, especially on this calculator. Well, I just wanted to show you that you can do that in a calculator. I'm going to stop sharing. If there's a question, Carissa, you think you are okay on it?
Yep.
Okay. In study hall, if you have a question, ask Carissa. It's second stack, sum of a sequence. I kind of wish we all had the same calculator, but they update this smart board every time a new one comes out. So sorry, but yours are still good. Mine that I have at home like yours, I still use all the time. Okay, I'm going to go back and share the smart board. So that's the first thing, sigma. Let's take a look at another one. All you see if you can do that one, with or without a calculator. Let's take about 30 seconds to a minute, 45 seconds, and see if you can do that. I want the sum, says sigma, I want the sum starting at 0, going to 10. So you have 11 things to do in squared. That's a real famous series of sequence, the integer squared. See if y'all can do that.
Sir, could you write on the smartboard what it would look like in their calculator? Maybe with the difference of calculators, that might help.
Well, let's take a look at the answer. If you're doing it by hand, you do what I've done here on the smartboard. I just say 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and go all the way to 100, which is 10. And then I add them all up. Is the answer 385? Anybody get 385? Technology is a great thing. It can't outthink us, but it can sure outcompute us, and it's a time saver if you learn how to use it. Let's see here. Any questions about that one? Any questions there? Well, let's look at the second item on probability. You flip a coin 3 times. We're going to look at some probability and ask questions. Flipping a coin is probably the easiest step that you'll see in probability and statistics because it's either heads or tails. And I'm going to slide, it says 31. There is the sample space for flipping a coin 3 times. I've listed all the outcomes. In probability, they'll ask you to list the sample space, and that's all the possible outcomes that you could have. And if you flip a coin 3 times, you can have 1, 2, 3, 4, 5, 6, 7, 8 different outcomes. 8 different outcomes. So I've listed the sample space with what's called a tree. I can list them by roster. If I wanted to list this by roster, I could say, I could have heads, 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 comma. I could have heads, heads, tails, comma. Now, next week, we'll look at some larger sample space, but let's start with the easy one here. It only has 8 outcomes, and I can see them all. Probability is usually written like this. Okay? Probability is some event. And all it is, you take the total of whatever you're looking at, and in this case, there's only 8 outcomes, and you divide it by what's in your favor. Now, what's in your favor it may be a good thing or it may be a bad thing. It's whatever the definition of the event is. And it seems so easy until you start doing problems. Well, let's do some with this. A is you get at least 2 heads. A is, that's the event. So I want to know the probability of A. What is it? Well, I already know half the answer now. It's 8. There's only 8 outcomes. I've shown you all of them. It get at least 2 heads. Well, here there's 2. Here there's 2. Here there's 2. Not here. Here there's 2. Not here. All the way down. So if I look at it, at least 2. The answer is 4/8, 1/2, or 50%. Okay? So the odds of winning, if I made this a game of chance, the odds of winning are 1 to 1. I'll win as much as the house does, or that's the way it should come out. That's what the probability says. Let's look at another example. B is you get exactly 1 tail. Now notice the quantifier is different here. It says exactly, where the one above it we said at least. So now I'm going to do that in blue, and I'm looking for exactly 1 tail. Okay, not here. Oh, here there's exactly 1. Here there's exactly 1. Not here. Here there's exactly 1. Not here, not here, not here. So if I look at that, what's in my favor is 3, and there were still 8 possibilities. So 3/8. Or 37.5. I think that's 37 if you want to divide it out. 37.5%. I think you might want to check me out on that. Is there a question so far? Usually in statistics, we start with this sample space here because you can see it and you can count it. In real life, when you're doing statistics problems, trying to solve problems like find a vaccine for the coronavirus, the possibilities are in the millions. So you have to have some basis to start. And this is the one they use in nearly all statistics classes. Okay. So we said the probability of A was 4/8. Probability of B was 3/8. We answered those. Now let's look at intersection. That's the intersection, upside down U, or union. Intersection means both. What's the probability that you get at least 2 heads and exactly 1 tail? Intersection both. Well, if I go back up and look at my chart, it's easy to see both. There's both here, both here, both here. And all 3 of those meet both conditions. So my answer to that probability question would be 3/8. Go right below it, and it says, what is the union? Union, put them both together, count everything. So if I count everything, here's 1, 2, 3, 4. Some of them are used twice, but it doesn't matter, I only count them once. So that case, that answer would be 4/8, the probability of 1/2. And that's a brief introduction to what probability would look like with a tree graph, flipping a coin 3 times. It's not the only thing, that's just a start. Next week we'll look at maybe a harder one when you draw 1 card from a deck of 52. That one's used in the statistics class because you can model it. Then instead of 2 outcomes, heads or tails, when you draw a card, you have 52 outcomes. There's 52 cards in a deck. We'll expand our sample space a little bit. Well, we'll do a few more examples here in a second or two, but there was that. Let's go back to where we were. So we looked at flipping a coin 3 times. Next is factorial. So let's look at some terms and symbols. The symbol for factorial is an exclamation mark. Sigma means to add. Factorial means to multiply. So they're symbols we use all the time, but we use them in a different way in mathematics. If I said n factorial, you start with 1 and you go up 1 each time and you start multiplying until you get to n. So if I said, well, tell me what 3 factorial is, it's 1 times 2 times 3, which equals 6. Without me going back to the calculator, try this, everybody. Clear your calculator. Take your calculator, clear it. Okay, put 3. Let's do this one on there. Let's make the calculator do that. Now I know you know how to multiply 1 times 2 times 3. But what if it was 87 factorial? I might want to help with the calculator. That's a huge number. It's over Google. It's over 10 to the 100th power. It's really big. So let's see if we can get the calculator to help us. Let's do 3 factorial and make the calculator say it. Everybody hit the number 3. Then under your green alpha key, you'll find a math key. So hit math key. And go over to where it says PROB, probability. That's your probability key. And number 4 is your factorial. Do you have this now in your calculator? Say something if you don't. Do you have that 3 factorial? And put enter. I bet it says 6.
Sir, can you hear
Is there a
me?
question about that on the calculator? Everybody do 10 factorial.
You might walk them through on the calculator screen how to do the factorials again.
Mine says
Have your
0.
calculator do it. You have your answer?
Mine says 0.
Dan, I think you can't hear it
Okay, let's see
again.
if we agree. 10 factorial would be 1 times 2 times 3 times 10. And that is 3,628,800. Do we agree on that? Is there a question? Calculator did that pretty quick, didn't it? To multiply.
Mine says
So let's go
0.
on with that.
Dan, can you hear me?
On n factorial, when we look at a factorial, it has to be a whole number. 0,
Yes.
1, 2, and on and on. It has to be whole numbers. All right? Does everybody understand that? You can't do, well, you can, but you're going to get in there. You can't do a half factorial. You can't do -3 factorial. The first 2 are defined for us. You say, what do you mean? I mean 0 factorial equals 1. The reason they define that as 1 is because later on they're going to divide by it, and you can't divide by 0. And 1 factorial is also 1. Outside of that, in other words, 2 factorial, well, that equals 1 times 2, or 2, and on the go. But these 2 are defined for us. It's built in, if you do them on your calculator, it's going to say that. It's built into the calculator. It just wants you to know when you do n factorial, n has to be an element of the whole numbers. Okay, we did 3 factorial. 1 times 2 times 3 equals 6. There's got to be a breaking point. Most of you are older calculators. Do 73, do 70, do 75 factorial. That's 1 times 2 times 3 times 74 times 75. Everybody do that in the calculator. Yes, Beth. Okay. You can't hear me. Okay, give me just a second.
And show them on the calculator.
Can you hear us? Test, test, test.
Can you hear me now, Beth?
I can hear you. Can you hear us?
John, can you hear me?
Yes, sir.
Okay. Beth, are we back to being good then?
I think so. I think it'd be helpful if you could show them on the calculator.
Okay. Here we go. And this will look the same. I'm going to do 3 factorial. 3 math. Go with probability. Number 4 is factorial, and it does it for me. It says 6.
Did that help, Brittany?
Let's do 10 factorial. 10
Yeah, I did.
math. Factorial. Enter. Math and probability. Also, I want you to look at number 2 and number 3. We're going to talk about those today as well. Permutation and combination. We'll talk, they're factorials, but we'll talk about them so you find them in the same place. You still good?
I think that helped a lot, sir. Thank you.
Okay, thanks, Beth. I don't know why it stops in the middle. Always call me like you did, Beth. I remember last time when I get a call, oh, must be Beth. So call when you do that. Again, that helps. Thank you.
Welcome.
Okay, let's go on and look at, we can look at those later. 0 factorial, I told you is 1. In probability, they'll ask for a permutation, and it's defined, if I want to do a permutation, 4 things, let's say 5 things, permutation 2 at a time. And now later I'll explain what that means or why we'd even use it. But right now I want you just to be able to do it. That is 5 factorial, which I can do by hand, okay, or I can do it in the calculator, over 5 minus 2 factorial. And that's 5 factorial over 3 factorial. And that would be 5 times 4 times 3 factorial. It's 5 times 4, 20. And now if you want to do it on the calculator, that math prob, it's right there with factorial. You have 3. If you did that in the calculator, you would put 5, math prob, you put probability, and do the permutation 2, and it would do it for you. The definition you need to know. Many of these you can do on your own. And there's several ways or reasons why we would want to use permutation and probability, but the first thing is you got to be able to do it. See if you can do that one. Either with the definition right here, or do it on your calculator.
On you guys' calculator, you'll put 4, and then you'll go to the calculator to that screen that Mr. Babcock just talked to you about, choose permutation, and then you'll end up putting a 3 in at the end.
Just like this. See if we agree or not. It's going to be 4 factorial over 4 minus 3 factorial. So I have 4 factorial over 1 factorial. 4 factorial is 4, 3, 2, 1. 1 factorial is 1. 24 is the answer. Either with or without a calculator. With or without a calculator.
Sir, can you show them with the calculator?
Beth, I'm afraid I'm going to be out of time. I'm going to work some of the classwork with them. I can, but it just takes so long. Okay?
Okay, maybe Carissa can do it during study hall.
Are you okay with the calculator, Krista? Okay. The last thing I want to show you is a combination, and it's very similar to permutation. And it might look something like this. The definition is exactly the same, but you add another factorial. So if I did 4, let's do 5. If I was doing 5, combination, 2 at a time, that would be 5 factorial. 5 minus 2 is 3 factorial, but you also pick up this, which we didn't do in the permutation. So it's a little longer. And the calculator will do it automatically for you. It would look just like this. 5 combination 2 enter. And there's reasons we want to do that. Right now, I just want you to see what you do. Let's see, that is 10. I bet the calculator says 10. Is that right, Krista?
Mine says 40.
40? Did you do it?
Yeah, for some.
Did it look just like this in the circle?
No.
I can help you guys put it into your calculator later, but there's if you use the math function and then the probability, it has the formula there for you. So I can help you with that later as well.
Okay, good.
Okay, here's the classwork. I want to get as far as I can on this to help you out today. First is sigma. We use sigma in statistics all the time. N plus 2 plus 1. So I'm going to start at 1, 2, 3, and 4. It says go from 1 to 4 on the sheet on number 1. If you put a 1 in, it is 3. If you put a 2 in, it's 5. Put a 3 in, it's 7. And put a 4 in, it's 9. Sigma needs to add. That's 8. 15 and 9 is 24. Is there a 24? The answer is C. Now, I could have done that with a calculator. There's a break point. In other words, I don't think that one's hard enough that I would want a calculator, but I could have used it on there, but you got to practice it like anything else. You flip a coin 3 times, you get at least 1 head. The only way you won't get at least 1 head, there's the only way. Does everyone understand that? That's the only way you won't get 1 head. There's at least 1 head all other times. So it's 7/8 is the answer. Well, I look up here and I don't see a 7/8. So I take my calculator and say 7 divided by 8, and I bet that's this right here. 87.5%. The next one, it says you flip a coin 3 times, and event B is you get exactly 1 head. Well, if I go to that sheet, in other words, I'm looking at the example I showed you a while ago, but you get at least 1 head. I could do this. I could do this. Or I could do this. So how many ways are there that I get exactly 1 head? How many are there? There's 3, right? So that's 3/8. And again, I would divide that out, and that's 37.5%. Number 4. Number 4 says, in the promise above, what's their intersection? What do they have? Both of them. Well, this is everything except this one. It's all of them. Well, that would take in all 3 of these. So this one's also 3/8. And that would be 37.5% as well. B is the answer. On this one right here, I could try to use the calculator, but it's not necessary because it's a division problem. 76 factorial is 76 times 75 times all the way to 1. And 75 factorial is 75 times 74 times 73 times 1. Those cancel out. 76 is the answer. 76 is the answer. And I'm not even sure the calculator would do this because these numbers are so big, but it might have done it on the calculator. Number 6, it's a combination. So I could use my calculator and I would make it look just like what I've circled. Or I could say it's 8 factorial. So this first one right here, 8 factorial, divided by, what's 8 minus 3? 5 factorial. And then I pick up the end one as well, 3 factorial. So if I want to work this out, 8 factorial is 8 times 7 times 6 times 5, and I'm just going to say factorial, 5, 4, 3, 2, 1, all over. And the reason I did that, I had 5 factorial times 3 factorial. These two cancel each other. 3 factorial is 3 times 2 times 1, which is 6. 6 cancels. So I'm left here, if I did it by hand, 8 times 7, and I look for the answer. 8 times 7 is up there. It is C. The answer is 56. Now, if you did it on the calculator, it would just come out and do it all for you. It would say 56. Krista, did you get that one on the calculator? Did it say 56? Okay. And the last one is a permutation. That's 10 factorial over 8 factorial. If I was doing this by hand, I'd say 10 times 9 times 8 factorial over 8 factorial. They cancel, and the answer is 90. Again, I could do it on the calculator if I made it look just like this. So you have all the answers to the classwork, and the homework's very similar. You don't have to use the calculator, but it's very helpful. It really saves time if you practice. And talk to Carissa, and if Carissa does a problem, give me a call. Okay? Beth, is there anything you want to add? Beth? Carissa,
Yes, sir.
is there anything you want to add?
No, I think we're good.
Let's see. Is there anything the group needs to add or want to ask? Remember, after the first 3 lessons, I'm going to do 3, and then I'm going to stop. On the 4th lesson, we're not going to add anything to. I'm going to review what we've had, all the topics. Any questions?
If you guys want to try the homework out, I'll also be at the lunch study session today and tomorrow too. So if you guys want to try it out before you ask for my help, that'd be great, and then we can go from there.
And it's at 1 o'clock.
Okay. Well, we're going to end the session, stop recording. Thank you all for being here, and I'll see you next Thursday.